sign it after like I put equal sign equal to 0, is it?
I really have to see your paper. I'm not able to. So either you shift the camera down or shift your paper. Okay,
Mm,
good, good. Okay, equal sign everything first. You trust me for now. Equal sign everything. Don't worry for now because you have to do it in a way that you feel confident and comfortable. You must understand that. So
mm,
equal sign everything, equal 0 everything, equal 0 everything. Everything equals 0, please. Okay, again, you are comfortable with the equal 0. It's just that you have certain small concerns. Lah. Am I correct?
mm,
I'm not forcing you to do something you are not comfortable with. The third line equal Kira, I want to pinch you. Okay, third line equals 0.
mm. Like this one.
Third line equal to 0. Okay, yeah, this one also equals 0 ma, from the start. Ma. And then at this point, you're going to do dollar. Ma. So do the dollar also. Lah, right? And the dollar is just 2 arrow. Like that is very nice one. The teacher will like it, right? And then you have your k equals to 0, right?
Mm,
Now, at this point, your Desmos is done. You are done. You are happy. You know you are actually more than halfway done. Mark-wise, they can only give you half lah if you stop here. Then that's fine. That's fine. Now, to complete everything, you just have to deal with the sign. Now, this is the time that you switch to your teacher's preferred way. What do I mean by that? Switching to your teacher's preferred method is extremely simple. Okay, extremely simple, extremely easy at this. I'm so sorry. Wait. Now look at page 3, please.
uh,
Oh, no, I'm sorry. I'm sorry. That's wrong. That's wrong. I create a new page 4. Okay, and then you must show me the paper. I will copy and paste. Sorry, yeah. I cannot see you're working right now on paper because the camera is too zoomed in. Let me copy paste your paper, please. You guys show me your paper. I cannot see your paper. There you go. Nice. Stop there. Okay, thank you. Okay, on the new page 4, go to the new page 4, please. Very long. Just a minute. What's going on here? Your teacher, your mom and dad is singing,
uh,
which is great. Which is great. I like
mm,
it. Now, Kirana, you see you're working on Jamboard, right? Is that like last time? Now, I promise you that to transition to your teacher's work is very simple and very easy. I promise you. Therefore, this is why I recommend you doing this in exam. We're practicing an exam method. It's not a method just for homework or just for learning one. I strongly suggest you do like this in exam every time. Okay?
okay.
You and this, if you want to follow or not follow, that is another decision. But you must understand first, I truly recommending that you're doing this in exam. So now teacher's method say at the start, which is here, you have to decide whether this is smaller or bigger. Just for your information, sometimes like this also sometimes like that, that kind of thing.
Mm,
There's always that combo
mm,
lah. So you make a decision right now, whatever you decide. For example, you decide that this is bigger than 0. All you have to do is this, 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 and then flip, correct? That's all.
mm,
And your teacher's method is done. It's really that simple. It's a little bit messy, but we don't care about that. We must care about how we understand while doing it. That's just how AMAT is. You cannot just follow blindly.
okay.
Okay, you understand me? Yeah? This is how easy to transition from teacher's method to from my recommended method to your teacher's method. Now, the question
Mm,
is, which one should I choose? That's the only thing you have to consider right now. Now, do you know how to choose? That is the question. This is now AMAT. Look, the choice of this is now the AMAT. Do you know how to choose?
mm,
your father likes to sing. I don't know that. I didn't know that.
Oh, what?
Your father likes to sing. I didn't know that.
Oh.
So it looks like the three of them likes to sing except you, lah, right?
My sister is not singing.
It's not singing also, right? Okay. Right. So okay, I hope you're entertained instead of, shall I go through how your teacher explains the choice?
Yeah.
I'll explain it fully and I will say to you, this works every time. So you don't have to think about another way. If you think about this, chances are you're thinking the right thing. Now, what am I saying? This is x-axis, okay? This is x-axis, okay? You draw this and then you just draw the 6 possibilities. The 6 possibilities looks like this, correct? It takes very little time, to draw these 6 possibilities. Okay? Now you draw this using pencil on your paper during exam. You do this every time and then it becomes a very good and helpful habit. I want you to do that on your paper using pencil. So it's like a working. Okay, I want to see you draw also. I need to see you draw, which is to say you gotta adjust your camera. You know what? Why don't you push the base of the holder down? Then you don't have to keep, shifting your paper, right? Okay. Now let me see you draw that on pencil. Okay, it's just just a rough drawing, right? So you don't have to be so nice about it. Okay. Kirana, your drawing is nice. Now, conceptually, I want to confirm with you. Is this the only 6 possibilities? Is there another possibility that we're missing?
I don't know.
All right, then think carefully. Think carefully. I'm going to help you understand why we draw this, because it takes very little time and it's supposed to be good, but you got to understand now. Now, here's a simple, I'm so sorry. Here's a simple quadratic graph, right? This one. If the quadratic move up, will it change type or will it stay it's the same type lah? Move up.
Wait, can you repeat again?
One more time. By Desmos, you know that the graph moves around 1 when you have a k. That's what the Desmos tell you. You remember that, right? Right? So with k, the graph moves around. The graph can move up. The graph can move down. You have seen it before. So we start with this flying graph. The graph moves up. The graph moves down. Okay, if the graph moves up, does it suddenly become, a different type, or this guy is enough to represent the graph moving up, so to speak lah?
What you mean though?
Okay, one more time, again, because the teacher doesn't explain this way. You know that the graph moves up and moves down, right? So for a certain k, so I'm going to draw another graph which moves up. There we go. Okay, and then another graph which is higher, and and so on and so forth. Like there's actually an infinite options there. I'll also draw the graph slightly down here, and slightly down here, but without touching it. So instead of drawing one red graph in the middle, I draw many graphs. My question is this. Is this red graph enough to represent everybody here?
No.
Then I will propose to you so that you feel this is like Desmos. Why am I saying that? Because this thing is a very Desmos-like thing that your teacher do. Correct or not? This thing your teacher do, right? Correct, right? Your teacher do this. then he's actually referring to Desmos in some way, even though he doesn't use. We are better lah. We use Desmos, you understand. So I am asking you to draw until you're satisfied. What you see in Desmos, you're recalling Desmos. If you feel that this is not enough to represent going up, then I suggest that you draw more for your convenience. Draw something that represents the Desmos going up and down. Because that's roughly what we're doing. Am I making any sense right now?
Yeah, kind of.
All right, then, because you say that this red guy is not enough to represent everybody, then maybe you draw more, look. Like me, you just draw a bit more just to help you. Oh, that's what it means, you know. Nothing wrong with drawing more, but doesn't take a lot of time. But, you know, maybe you stack it up here or, maybe, you know, something like that, you know. Something that makes you feel that you are recalling Desmos. Okay, let me see. Okay, you're drawing a lot, but you are stopping at not, you know, you're not touching the line, correct? And so you're happy, you're quite happy, look, okay, Desmos kind of does that, so I do that here. Now, why do you draw the second guy? Here's the first guy, here's the second guy. So the first guy is now a big group, okay, and that's totally fine. Okay, let's call this the first guy, but it's a group. The second guy is here. The second guy is the guy touching the line. You are basically separating this guy from this group, correct? Your teacher does that also. I mean, admittedly, your teacher does that also. I also do that. But the question is, do you feel like doing that? Do you feel like this guy is different from all the other guys?
Yeah.
Okay, then separating them to the right is a good thing. Okay, it's a good thing. And there is only one possibility of this guy, so you don't need to add anybody else here, correct? Now the third guy. The third guy, teacher separates from the second guy. I also separate. The question is, do you want to separate the third guy from the second guy? Is the third guy to you different than the second guy?
Yeah.
Then it's a good idea to separate them. Separate it up. Right? So now the question left is, do you feel like drawing more of the third guy, you know? Do you feel like drawing more? If you feel like drawing more, then draw lah. Because Desmos also do that what? Right? This is just you recalling what Desmos. Hey, the last guy you draw doesn't make sense. Because the last guy you draw is on the first group. Am I making any sense?
Yeah.
So don't draw the last guy because you already draw in the first group. Okay, so what we're drawing represents the Desmos. So Desmos does this. You see here, Desmos does that. Desmos just nicely give you everything like that. Correct? Now, the flip guy. There's also the flip guy, so you can flip, and then you know what? Do you feel the need to draw more, or you know, just one is enough? Because this just means the same thing. If you want to draw more, you draw more, no, that's fine. If you don't want, that's fine. So you draw more, but the last one you draw touches the line. Are you sure you want to do that? That feels confusing to me. So back to the original question, yeah? Do you feel like this represents every possibility you see in Desmos?
Yeah.
Right. Then this drawing has some meaning to you. Okay, it doesn't take long to draw. It reminds you of what is important. Now back to the business in hand. Your teacher will say, if you choose the right one based on what the question wants, you will be able to choose the sign. So you understand what your teacher is saying. Your teacher is saying first, choose the right drawing first based on what the question wants. It's not choose the sign first. People does that all the time. People choose the sign immediately. Nonsense. They don't understand this topic. This topic is you choose the appropriate graph first, according to what the question, which is the same as doing things in Desmos. So you tell me, Kirana, which one represents what the question wants?
I point to you with my pencil.
Or you just circle the thing that you think is correct. You just circle it. If you want, you can circle it. What does the question want? When you circle that, okay, I'm going to follow your circle. You're circling this one. Do you mean that it's everything or it's just this small part?
Everything like after the line.
Then just do a bigger circle here just to clarify. Correct. It's more like this one, right? Oh, you're choosing that. And you know what? I totally agree with you. I totally agree with the way you read the question. Lies completely above the axis. It must be that group lah. Now, that's what the teacher wants. It's just that sometimes when teacher explain, people think that I immediately must choose a sign. That's just wrong. That's just skipping the whole thinking process. In Desmos, you choose this, and in your own drawing, you choose this. Now, what the teacher wants you is that because you choose this, you are able to choose which sign. And then he goes and tells you something important. If the discriminant is positive, some people say it's positive. Some people say the discriminant bigger than 0. Can you accept that these two means the same? Positive means bigger than 0.
Then both the same.
Correct. But you must understand you have a preference. Everybody has a preference one. Do you prefer to be set as, discriminant positive, or do you prefer discriminant bigger than 0? You must be honest with yourself first. Which one's less confusing?
The one with the arrow.
You mean you prefer discriminant bigger than 0? Correct?
Yeah.
Okay, then that's great, because that's usually what the teacher do. That's great lah. Now, the teacher will tell you, sometimes with explanation, sometimes not that. These two guys, is discriminant bigger than 0. Always, always, always. Maybe they explain, maybe they don't. And then your teacher go on and say, this guy is discriminant equal to 0. Always, 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 no matter what. And then for the last one, these two guys, he will say, this is discriminant smaller than 0. Maybe he explained, maybe he don't. If you don't understand his explanation, you memorize. I'll make it clear as fast as I can. Discriminant bigger than 0 is where the intersect is 2. There are 2 intersects for this one. Discriminant equal to 0, only one intersect. And discriminant smaller than 0, no intersection at all, no touching. Your teacher will also say something like this. Are we okay so far?
Yeah.
I will show you more in hopes that this makes it understandable. If this confuses you, I will stop. I'm explaining more. Remember the formula you already learned, minus b plus minus b squared minus 4ac over 2a. You remember this, huh? I told you during holiday tuition, do you realize that this guy is the discriminant? The guy inside the square root is the discriminant. Do you realize that?
Yeah, because it's the same as the one.
Correct. And they intentionally take this guy inside. That is what they are trying to do. They are not trying to invent a new thing. They're just trying to take some part of that formula. That one I told you in holiday tuition. I told you that this guy is somebody and this guy is also somebody. That's the somebody. Now, what does this have to do with the two intersect, one intersect, and no intersect? There is the very strong connection. This formula is supposed to help you find the intersection. Do you understand? This is the formula lah. This square root, if the inside is positive, this will give you as a square root two numbers. That's what they teach you. If you don't understand what I'm saying, square root 4 is you're supposed to now write plus minus 2. This is EMAT. This is not AMAT at all. This is EMAT. When you press the calculator, what does square root 4 gives you?
2.
Correct. Can you accept that you are supposed to think like this, smarter than your calculator? Smarter than your calculator. If you don't understand this, tell me, because this is email.
What do you mean smarter than my calculator?
Because your calculator only gives you one answer.
Yeah.
Always and always. But you are trained to think, if it's square root, there are actually two answers, one. And one of them, you have to remember yourself or think yourself or understand yourself, because the calculator won't tell you. So square rooting a number is supposed to give you plus minus something. Two numbers. Yeah. Okay. So that's square root 4. Now 4 is a positive number, right? Square rooting 4 gives you two answers. Look at this formula. Obviously, it'll give you two answers just because of that. Now, what happens when the inside, the discriminant, is 0? What does square root of 0 give you?
0.
Correct. Which is not two numbers. Correct? Plus minus 0 is just 0. What are you talking about? Yeah? Understand? Plus minus 0 is just one answer. Therefore, when the discriminant is 0, look at that. When the inside of the square root is 0, this formula only give you one. There one answer lah. Correct one. Only one intersect. That makes some sense. AMAT is just stealing from EMAT. Something like that.
Yeah.
Now, what happens with your calculator when you square root a negative number? The inside is negative. That can happen. That can happen. For example, square root negative 2. Do you know what happens? If you don't know, just press your calculator.
Math error. Math error.
Let me tell you what math error is. Math error is not that you type wrongly. Math error means the calculator cannot do. Math error means calculator cannot do. Calculator error. Calculator very confused. What does that mean? Very simple. Very simple. There's no answer. The calculator cannot figure it out. So, square rooting a negative number, for your case, you can simply follow the calculator and say, oh, there is no answer. Math error, man. Math error means no answer, man. Okay? You can do that. Conceptually, you can say that. Why am I telling you all this? Again, if the inside is positive, how many answers from the formula?
1.
2 is positive 2. Come on, come on. Square root 4 plus minus 2. Hey, 2 answer ma. 1 plus minus ma. Plus minus. Okay. If the inside is 0, how many answers?
1.
1 answer. If the inside is negative?
No answer.
And therefore, this is the situation. No answer. Discriminant bigger than 0. 2 answer. Discriminant equal to 0. 1 answer. Discriminant smaller than 0. No answer. Which is visually, it means it's flying. No answer visually means flying. You must understand that it is visually flying there.
Okay.
Now, this whole explanation, does it make you feel better or not?
Yes.
So it makes you feel better, then you remember it because that's always what happened in something. Now, why this long explanation? Because I'm trying to connect your visual representation, which is wonderful, with the sign you're supposed to choose. A long explanation. So which sign do you choose? Do you know which sign to choose now? If you choose this group, which sign are you supposed to choose?
The one the one pointing the 0.
Write it down for me. So now you are changing the sign, right, into what you think is correct. Use your pencil first. Use your pencil. Use your pencil. You have chosen the right group. So now time for you to change. No, up there. You must choose. You must change the sign here. This is where you change the sign at the start. Remember I'm saying you're changing from my method to your teacher's method. So you only have to do is change this sign, which the drawing tells you, right? So what sign will you choose? And you have chosen correctly. Do you understand that you're correct? Do you know why you're correct? Do you want me to repeat the reason why you're correct?
I mean, cause like the graph like already like above 0, so like the arrow for the last answer have to be more than 0. Then like the working like behind the answer have to be like the reversal.
Now I have a bad news for you. Your logic is wrong. It will cause you to make mistake in another question. That was not the logic. That was not the logic at all. Definitely not. Because half of the time you're correct, half of the time you're wrong. You're just choosing between two signs. One. So if you use this logic, sometimes you're correct, sometimes you're wrong. And you wouldn't know why you're correct and why you're wrong. Because the logic itself is wrong, but the option only 2. So 50-50, your chance of being correct. Do you understand what I'm saying?
Yeah.
The logic is what I explained to you. This is the group you choose. This group has no intersection. Oh, that means, according to the formula, the guy inside is negative, no? The discriminant, the guy inside, is smaller than 0. And that's why you start here with smaller than 0. If you remember my explanation, that is why I explained that to you. Tell me if that doesn't make sense.
Can repeat the explanation one more time?
You choose this group. It's the correct group. Correct?
Yeah.
This group is supposed to tell you the condition of the discriminant. So now you tell me, if this is the group that you choose, what is the condition of the discriminant?
The condition.
Condition means the discriminant must be like this one, or discriminant must be like that one.
Like
The discriminant, if the discriminant is positive, will the graph look like this?
yeah.
No. If the discriminant is positive, the graph will look like that. Who answers to intersects? Believe it or not, you say yes to that just now, and you totally do not remember it, which means you don't understand it, basically. It's not that you don't understand it. Okay, Kirana, we probably cannot spend a lot of time in AMath like this. So I'm going to take a shortcut. Would that be okay? So I'm going to say something which summarizes everything. I'm going to erase this. Erase this for a while. Okay. Hi. Just drawing that, right? Okay, Ken? And yeah, these are the situation like here you draw more, something like that. Correct?
Yeah.
Obviously, this guy is the flying one. I'll call this the flying one. Would that be okay? The flying guy, you remember discriminant smaller than 0. That's all. That's all I'm asking you. The flying guy, discriminant smaller than 0. Ken, I'm asking you to memorize this. This will always be correct, Ken. Okay, Ken, yeah? Ken? Kirana, is that okay? I'm asking you to memorize. I'm not explaining. I need an answer. If this is not okay for you, at least we can do something else.
So if it's flying, the discriminant is
Smaller than 0 will always be correct. That is what you memorize. Flying here. This guy also, by the way, this guy also smaller than 0. Okay? That is what I'm asking you to memorize. If you apply this, you will get your final half mark, the other half of the mark. Okay. Because you're already at half mark at this point, because you follow my method. Okay? This is for you to transition to the other half. Now, where do you apply this knowledge? I choose the correct guy. Oh, it's discriminant smaller than 0. I memorize. Where do you apply it?
Like the first few.
Correct. As in the first one. And then you just continue downward. So since you're already correct, you feel free to now use your pen. So because if you want to correct it and the presentation be acceptable, you have now to pen everything. So you have to pen everything. So try your best to change the equal sign to that line. Okay. If you cannot, I guess you just the easiest way, the fastest way in exam is just to do that and then like that. That is totally acceptable. That is the fastest and totally acceptable way. Yeah, please don't bother to be how do I say it, to be tidy, right? Okay. This is tidy enough lah. That works. Works pretty fine. Works nicely. And then the last guy will flip because of AMath, and then you have the correct answer. With one memorization, the rest is understanding. This is our compromise, Kirana. Can you accept this for now?
Yeah.
Okay. Are you ready to do 9B?
Yeah.
Give it a try. I'll follow you lah. On paper, yeah, on paper. I mean, if you want on Jamboard first, but if you, yeah, up to you, yeah.
Do I do b square minus 4ac?
Discriminant is always how you deal with it, at least according to your teacher, right? Always. Okay. You must remember that I teach you, okay, do discriminant, just equate it to 0. That's what I teach you. And you proceed from there.
So in front of k is 1.
No, not 1. You're wrong. A is not 1. A is sorry, aduh, Kirana. Not that equal to 0. I never say that here. Please don't mix it up. That's the graph. The graph is not equal to 0. Graph is just the graph. The discriminant is equal to 0. Please don't mix it up. Okay, in your discriminant, you need b squared minus 4ac. You need a, b, c. You tell me what is the a here? The guy in front of x squared, minus 1. Very good. It's not 1. It is minus 1. Go ahead.
Wait, then k is just k.
Sorry, you gotta move up a bit. No. So Jamboard in Java, I can follow Jamboard. Sorry, okay. Don't say k. No. Okay, no, not good. No. Just write down for me. Just write down what is A, what is B, and what is C. You gotta write down. This prevents you from being confused. What is A? What is B? What is C? Okay, totally agree with you on A. And then I can follow you on B, and your C is, you gotta make a decision. Yes, you gotta think for a while. Stop for a while and think. Very important. Because your C is correct just now. Just now is harder than this one. Let's settle this confusion. This is very good. Because this is still A math. This is still partly E math. Good. What's your decision, Kirana? Are you confused?
Is it just K?
And K is correct. Now, why are you confused? Do you want slightly more explanation?
No.
All right, then you are correct. You're correct. All right. Now remember what I teach you. You are still not applying what I teach you. What do I teach you? Okay, very good. Equals to 0. Good. Immediately. Because that's what you do in Desmos.
Is it like that?
Okay, I'm following through Jambo. Okay, there you go. And your decision is smaller than 0. You didn't draw anything, but let me just confirm how do you think lah. So why do you decide is discriminant smaller than 0? It must be based on the drawing. I noticed that you don't go there one. It's a problem that we have. So I want you to go to the drawing. The drawing is at page 4, all right? Page 4 there's a drawing. It's the same drawing. Page 4. Those are the options. So when he say always negative, that's what the question say, right? Always negative.
Yeah.
Which graph are you thinking about? Which group? Which which one?
Do I circle?
Oh yes, please circle. Right. And I totally agree with you. Visually, that is always negative. You're strong visually, Kirana. I like it. Okay, and you're using it to your advantage. Your teacher also suggests that. This group does belong to discriminant smaller than 0. It does. Therefore, your choice is correct. Okay. And when you continue, let it know. It's just that, oh no, you don't have to flip. This one you don't have to flip. You're totally correct. Totally. Okay. Now, Kirana, we take a long time. I don't mean that's bad, but we take a long time to try to understand. I just show you how to do it. It's a very short, how to say, short working. You see that? It's very short. Maybe 3 marks in exam, right? Quite exam level. But we take a long time because you're trying to understand. Are you comfortable with your level of understanding right now?
Yes.
Right. Then let me repeat because you're going to the next question. I say you must Desmos first. Then you try to do presentation, but my method first. And then you switch to your teacher's method. Desmos, my method, your teacher's method. Understand? Okay, let's try. Let's try. You are now at question 12. Okay. I'll put it down for you. Don't need to write. Put it down for you. Right, there you go. Now you do it Desmos. Cannot see your Desmos, but you're supposed to derive an answer. Now, in this question, of course, it asks you to explain. So Desmos should what does Desmos supposed to tell? Okay, I cannot even see your iPad. Come here, iPad, go up, please. Okay. Okay. You're putting it at -5, right? Which is what the
Yeah.
question wants, right? So just a slightly different angle, right? But no worries, very easy. Does the Desmos tell you that does the Desmos tell you something?
It's not touching the X.
Axis lah, right?
Yeah.
Which is that what the question is trying to say?
Yeah.
All right, so Desmos does kind of, if you could just submit Desmos to your teacher, right? The Desmos answer it all. Correct?
Mm.
Am I making any sense? If
Yeah.
you can just submit this, okay, then Desmos is giving you the answer just like previously. Okay,
Mm.
just like previously. Now, do you know how to approach this?
Do the discriminant thingy.
I guess for this topic, that always is a good idea, even though you might not know why, always. So let's try that. Hey, stop. Sorry, wait. Can I wait. Can I wait? Stop. I know you're following what I'm saying. Okay, but this question is a little bit of a twist. This question basically says that K is a number. That's not the case at all with all other questions. All other questions, the K move around one,
Oh yeah.
correct? But this one, he fixed it.
So
Basically,
I
you have
replace
no K
K
with minus 5,
minus
right? Which you cannot equal to 0. Let me explain. Wait. So let me explain. So listen to me for a while. Listen. Kirana, in E math, there is no K. Did you remember me saying that? In E math, there is no K. In A math, there is K. Okay. That means in E math, the graph is not moving around. The graph is fixed because no K. Okay. In A math, they move the graph around. Graph moves. Correct? You understand?
Yeah.
Graph moves, there is K. Now, think about what they do in this question. He make the K into a number, right?
Mm-hmm.
Does the graph still move around?
No.
You understand what I'm saying, right? Suddenly, this is an E-math question because practically speaking, there is no more K because the K is already fixed. Hey, if the K is fixed, the graph is fixed. That's not A-math. That's easier than A-math. Think like that. You understand me?
Uh-huh.
So if the graph is fixed, you're not even supposed to consider too much of the A math method. Not to mention equal to 0. I mean, equal to 0 is totally unnecessary here because the graph doesn't even touch. The graph will never touch us. The graph doesn't move. Right? You understand?
Yeah.
From Desmos, you know that the graph is not touching, so don't equate it to 0. Secondly, put minus 5 here. Right? Put minus 5 here, and then you'll get something else.
Okay. So I erase.
You don't have to. You can just continue doing the discriminant for a while. If you don't understand why, we'll check again.
I write at the bottom.
Okay, sure. Okay. Okay, then. Oh, come on. Kirana, you're the lady with the minus problem, right? You're the lady with the minus problem. You always have a minus problem. Come on. Okay. Is this you being tired, or this is just you being normal? No, you also did this. No, you also did another mistake. No,
it's just
not like that.
confusing.
Okay, tell me why is this confusing? Please tell me.
Cause it's minus k, but then
Yes.
k equals minus. So 5 should be positive.
You can think about it that way, or I propose something like this. I'm trying to propose something that is the least confusing to you. I want you to be more clear, okay? That is always how I want to propose things. If this makes you less clear, you gotta tell me. Rather than think about it, just write it down as it is first lah. There, minus k, minus 5 lah, plus 1. Some people even don't bother with the bracket. Some people just write this. And I mean, in some sense, that's okay. I mean, why bother thinking about it?
In my exam, they don't allow like that.
Look, no. Again. I know that there's an exam concern. I know. We'll handle it later. Okay. My question to you is this clear to you? You don't worry about them first. You cannot even do it correctly. Okay, this is clear to you, correct? This is clear to you, right? Which means you have two options. If you write down this way, then good news to you, you can now present to them because it's now clear. Look, Kirana, you cannot present to them correctly if you don't even understand. Now this you understand, correct? Minus 5. Then forgo the bracket, just whack like that. And this one. Make sense?
Yeah.
I mean, the second option is minus 5, and then you just put a bracket like that. But since you know what minus means, then just whack plus. Even better. Now, which one do you like?
I think the positive 5.
But the requirement is you minus first to avoid confusion. And then you can fulfill what they want. Your presentation is fine with the plus. They will not penalize the plus. Okay? Have we fulfilled the true criteria? You are clear, then they are happy. Okay, then please do it like this. Minus, then plus. Every time I will ask this from you. I will be able to see whether you minus 1 or not. Now, once you do the minus, immediately just plus it. Like you don't have to rewrite. Just plus it like that. Whack like that. Just like me. Just like this one. Yeah, something like that. And that minus, that plus is obviously from a 2 minus. And so I know what you're thinking straight. Okay?
Equals minus 32.
And this is the discriminant, correct? The discriminant. Of course, minus 32 is not equal to 0. But you're faced with this, so to speak, weirdness or problem, because this question is not a usual AMAT question. A usual AMAT question never fix the K1. You always let it. Okay, clear, yeah? So suddenly you have a discriminant, which is also not floating. Usually a discriminant is floating one. It's something K. It's not fixed. This one is fixed. Now at this point, you have a few options. Yeah? You can recall what the teacher said to you. I've been trying to explain this to you. Hey, this discriminant minus 32, well, it means that the discriminant is negative or discriminant smaller than 0. correct? That's what
Yeah.
it means. Oh, don't you remember from your graph, I asked you to, I asked you to memorize something, right? Do you remember I asked you to memorize? You don't remember, you go back to page 4. Come on, I asked you to memorize something on page 4.
Discriminant always less
Smaller than
than
0.
if it's floating.
Flying. If it's floating or flying, and it looks like what you're drawing. Now we go back to this one. In that drawing, you go from, oh, it's floating. Therefore, discriminant smaller than 0. You go from floating to discriminant smaller than 0, correct?
Mm.
In this situation, you start from, oh, hey, wait a minute, is discriminant smaller than 0? Oh, wait a minute, that's weird. Usually I don't start with that, correct? Usually I start with the graph. But you can just reverse the process, ma. If discriminant is smaller than 0, that means the graph is floating. Correct?
Yeah.
You can just go backward. Now here's the good news. If you can do that, then that's what your teacher expects. Your teacher will expect you to write discriminant smaller than 0 from here. Draw this, and then that's it. Finish. That's what the teacher wants.
Oh.
Because that's what they understand, that's what they learn, and that is what makes sense. If you understand it, that is really what it means. Oh, discriminant smaller than 0. Oh, it's floating. What? Floating, no intercept. What? Correct or not? Floating means no intercept. What? Correct or not? And that's all you need to write after minus 32. Do you understand?
Oh.
Does this make some sense?
Yeah.
Then go ahead. Just remember that this is very unlikely to be an AMAT question. AMAT questions are usually not like this one. It's harder than this one usually. Yeah, because they want the graph to move. Move is harder, ma.
The answer says 9B is K. K is lesser than -4.
That's 9B. You're talking about question 12.
Eh?
Are you tired? Are you tired? Tell me, Karana. Are you
Wait.
tired right now? Are you sleepy now?
No.
Are you sure? You sound kind of sleepy and tired.
Never mind.
So, what does the answer say? Because this one, the answer probably won't say anything.
No answer.
Correct. That's how they, a bit annoying lah. They just don't give you any short answer. But then I tell you the presentation. Anyway, you did Desmos. Anyway, you kind of understand it. So I guess for now, you accept that this is correct lah. Okay?
Yeah.
Kirana, are you sure you're not tired?
No.
Okay, I'm going to show you my face. Hi. Okay, you can see me?
Yeah.
Now, you show me your face.
Huh?
You show me your face. I guess you don't look tired lah. Okay, let's continue. No need video. The approach I suggest is Desmos, right? Desmos, and then something, right? Now, I will add one more thing. I'll add one more thing to my method. Is this A math, meaning the graph is moving, or is this E math, meaning the graph is not moving? So the question is the graph moving or is the graph not moving? Okay, yeah? You understand what I'm saying?
Yeah.
So in question 12, the graph turns out to be not moving. supposed to be simpler lah. You can see the working, very simple.
Mm.
13.1. Is the graph moving or not moving? Okay, Kirana, is this confusing? I'm asking you whether the graph is moving or not.
Need to reload the page.
You mean you're going to Desmos, is it?
Yeah.
Okay, which is you're following what I'm saying. But before you do Desmos, I'm gonna stop you for a while. Kirana, stop you for a while. Huh? Can't you make a guess whether this graph is moving or not? Can't you make a guess before you type everything?
Not moving.
And you are correct, Kirana. Okay, you are correct. Now go ahead, do something on Desmos. You're correct. And not moving, you know what it means. Oh wait, this is more like email. What?
Where's
Kind
it
of
red?
like this is like you're saying?
Why is the graph red?
Oh, a very good question. But I do know why though. No, I do know why. I do know why. Okay,
Yeah,
Desmos is
green
not
just
sometimes. No. Desmos is sometimes not as smart as you want it to be. Now let me teach you how to do it. You erase until the bigger sign. Just erase 4 minus and the sign. Just erase that first. Back. One more. Okay, then you go to the front and type y equals to, just like normal.
at what?
Go to the front. Go to the front.
Oh.
And just put y equals to, just the normal thing you do, right? Okay, then go to number 2. Let's click number 2. That's in graph number 1, graph number 2. You can go below this graph. The typing. No, not that. No. Oh,
Okay.
here's. There. Okay. Then you type y equals to -4. Now, you stop there for a while. Okay, you see that -4 is below the graph, correct? Okay. Now, this is our way of helping Desmos. Desmos not very smart. Okay, the question asks for 2x squared plus 2x bigger than -4. So what we do for Desmos is we draw 2x squared plus 2 lah. And then we also draw -4 separately for the Desmos so that we can see. That's what we're doing right now. Desmos not very smart. You understand? Now, 2x squared plus 2x is bigger than -4. Well, does the Desmos tell you that?
What?
One more time. The graph 2x squared plus 2x is in front of you, the red graph. The -4 is another graph, a straight line, the blue one. Is the red one always bigger than the blue one?
No.
Okay. So move your iPad up a bit. I cannot see the blue line. All right, look at that. Now the red guy, the red graph, can it move or not?
No.
Fixed, right? Because there's no K. The -4 can move or not?
No.
All right, there's no K. They're both fixed. So the red graph, is it always higher than the blue graph? Blue line.
No.
What do you mean by no? Show me a place or position or an area where the red graph is not higher than the blue line. Okay, why are you canceling the -4? So I don't get it. -4 is -4 what? You don't get to shift the -4 is not moving around, at least not in this question. Look at the question. 2x squared plus 2x bigger than -4. Well, we separate them to x squared to x and minus 1. There you go. Is the red graph always higher than the blue line? If I'm not making any sense, tell me. Don't get to shift the blue line because there is no k. Blue line is blue line.
No.
Okay, sorry, when you say no, sorry, the red graph is not always higher than the blue line. That's what you're saying, right?
Yeah.
Or then show me where, in which area is the red graph not higher than the blue line.
How?
Oh, I don't know how. You're the one that say the red graph is not always higher than the blue line. From my perspective, I think the red graph is always higher than the blue line. That's my perspective. That's my opinion. I don't know how to show you that the red graph is not higher than the blue line because I don't think like that. I think the red graph is higher than the blue line when I see Desmos. So that's why I'm asking you. How come you think the red graph is not always higher than the blue line? We must talk about this visually. Let's not talk about using methods or algebra. Just visually like that.
Mm.
What makes you think that something like that? Or what is confusing you? Also fine.
If like the red, isn't it like if the y for the red line like negative, then it will like go lower.
Sorry, what you saying? What you saying, Sasi? What you saying?
Like if
Repeat
the
again.
red, like the red line, like the y equals 2x squared plus 2x,
Yeah, that
like,
one.
it won't it like be lower?
What do you mean by you put negative? Sorry, tell me again. What do you mean?
Like, because I say not every time the red line like always like on top. So I thought like if it's negative, then it will be like below the blue line.
Let me clarify what you're thinking because it's important. Okay, math. You're saying that the red graph is not always at this position. You mean the red graph can move. That's what you're saying, correct?
Uh,
That's what you're saying, correct or not? The red graph can move what?
only if got K.
Yes, Kirana. Your name got K, you can move. This guy don't have K. It is fixed. I mean, it is simple in that way. You don't have to imagine it moving. I like that you're imagining moving, but this time it's fixed. So it doesn't move. Are you okay now?
Yeah.
So Desmos is telling you this fixed guy is obviously always on top of the other guy, the blue guy. Obviously, because they are both fixed. They're both fixed. Okay? An easy conclusion because they are fixed, because they don't move. Okay, so Desmos is again giving you an answer to your homework. If only you could give Desmos. Hey, it's proven what? See? Just look at the graph, right? Something like that. Okay? All you have to do now is translate your understanding from Desmos to what your teacher wants, which again usually involves discriminant. Usually. Okay, come, you have 3 more minutes.
Do I do the b square minus?
But if you want to, I'm trying to make this simple thing. I'm trying to make the simple thing simple. Yeah, okay. Let me try to explain. Oh wow! I understand what this question is doing. Okay, Kirana. In this last question, I have to explain something. I have to explain something. Might not be enough in these 2 minutes, but lucky or not, I have to try. To be fair, this is what I needed to explain when things get hard anyway, right? So I'm surprised that we end up with this question, right? Now, let me ask you to go to Desmos. Let me ask you to go to Desmos. All right, and I'm going to ask you to type one more thing, yeah? So number 3, graph number 3. So you have 3 things. So y equals to 2x squared plus 2x, the same thing. Y equals to 2x squared plus 2x.
Yeah.
It's just the
right.
same thing as the red one. Oh, no. You type that in the number 3 because there will be a modification.
Oh.
Plus 2x, all right. But one modification is plus 4. Okay. Now, why am I asking you to do this, right? So let's go back to Jamboard for a while. Let me explain. Instead of doing this, I am changing it a little bit. Okay, instead of doing what the question says, I am changing it a little bit using Doldor. I'll explain why I'm doing that. Okay, so I change it a little bit to x squared plus 2x. I just plus 4 plus 4. That's the Doldor. So now I have a plus 4 here and then bigger than 0. Would that be okay for now?
Yeah.
All right, so this is a simple change using Emath. Let me explain why. Now, in Desmos, there is no problem dealing with this. I say that Desmos is stupid, right? Desmos stupid, you cannot handle this. But actually, Desmos is very powerful. Desmos can handle this guy. Desmos is great. It's just that I need to speak to Desmos the way Desmos understand, right? The algebra way, which is what your teacher wants, cannot handle something like a simple minus 4 on the right-hand side. Cannot at all. The only thing algebra can handle is where basically there is, well, nothing on the right-hand side. 0 lah, basically.
Mm.
So, because I know the limitation algebra, you may not appreciate that limitation itself. So, what's so annoying algebra? But I'm telling you that algebra is limited. So, I gotta move everything to one side. That's why I do the Doltolo so that there's nothing left on the right-hand side. Right-hand side is now nothing. Okay, now
Yeah.
only this can be handled by algebra, which is what your teacher is teaching. Whereas Desmos, no problem. Yeah, so I'm telling you the limitation of algebra again. You cannot handle if there's something on the right hand side. You have to believe me for now. Go back to your Desmos and look at the Desmos. I'm going to copy paste your Desmos, yeah? I'm going to copy paste your Desmos. Okay. Now, I already have your Desmos on the Jamboard. You go back to the Jamboard. Very long, sorry. So sorry, it's very long. Okay, so Desmos can handle these two guys, correct? Desmos can handle it and show you clearly.
Mm.
Algebra cannot. Therefore, algebra, frankly speaking, changes the original graph. When this original graph, right? Original graph, and then when I plus 4, obviously this is no longer original. This is now new. This is a new graph. Even Desmos agrees with you there is a new graph. Okay, the algebra method say, forget the original thing. I can only handle the new thing. I cannot handle that thing. The new thing is not touching the x-axis. The new thing is not touching the x-axis. You will arrive at the same conclusion. Let me repeat one more time. Huh? Desmos handle this perfectly. Algebra cannot. Algebra decides to create something new that he can handle. If this sounds confusing to you, I'm sorry, we have to leave it like that. But this is how they will do things. Can you at least accept that for now?
Okay.
Thank you for accepting, because I don't think it makes a lot of sense right now. How come algebra so limited? But if you can accept that for now you do your discriminant here. This is where you do your discriminant. The new guy, not the old guy. Because the old guy will mislead you if you do discriminant. There's a limitation of it. If you apply the new guy, that's okay. Yeah. Gonna be fine. Okay, can you accept that? You do that, I'll wait for you, and then we'll end today. Come.
I do the b square minus.
You can do the b square minus 4ac, but on the new guy, not on the old guy.
Do I still put the arrow and the 0?
You don't put equal to 0. You also don't put arrow. Why?
Okay.
Because there's no k. This is like a weird A math, right? A fixed A math. When there is no k to put, you don't say whether it's equal to 0 or bigger than 0 at the start. You don't say that. You just work it out. The discriminant is very obvious when you do it. See what I mean? This discriminant is so much easier than the previous question. Very weird, right? The previous question has k and everything is not. So my discriminant is minus 28, which again leads you to what kind of conclusion? Come on, discriminant smaller than 0. Therefore, the graph is floating.
Wait, but what does all real values mean? Is it like
I'll explain that. All real values in this situation simply means all x's. So what does that mean visually? It means that along the x-axis, does that make sense to you? Along the x-axis, everything, all real values are there. So add the whole length of x-axis. Basically everything. Again, does it make sense visually? I want you to make sense visually.
Yeah.
Okay, sure thing. Good question. And I suppose to your surprise, part 1 already answers part 2. Already. Absolutely. It's that. Because part 1 requires you to change it into a new thing, which is part 2. Which is part 2. Okay. This old and new thing, original and new thing, will feature from now on. From now on, AMAT will be like this. You will see a lot of things like this. They give you something, and then you have to change it to something. That's my promise to you. Okay, this is your Sunday. How do you feel?
I think I understand AMAT better.
Good for you. Hopefully, we can spend more time like this next week, but if we cannot, we must know our priorities. Okay? Having said that, I am happy that I think I'm strengthening your email also today. Always happy. Okay, good job, Kirana, for 3 hours. I will see you next Sunday.